And so it really is just I'm very honored to be able to be here to be able to speak about digital manufacturing. I have to say, obviously, very excited about the implications for digital manufacturing and how the impact on the things that we make. Not only how it increases that innovation will increase efficiency and responsiveness in terms of promoting other innovations within manufacturing and goods, but almost how it I foresee a resurgence of where we started with cottage industries. With this technology of all those great innovations that we take for granted today that started in basements and started in garages or back rooms or in living rooms. This is a great innovation that will once again stimulate that. And those are the kinds of things in the past, that innovation by entrepreneurs is what built our great nation and really led us to be successful economically and technologically and all the great kind of the innovations and inventions that we enjoy today. So this really, the word I wanted to use was a quantum leap forward in manufacturing, and maybe somewhat of a quantum reach back to those cottage industries days as well, in terms of where we grow this from. Allowing objects to be rapidly printed, in the case of cyber manufacturing, obviously printed remotely. Since 2009, I've had the privilege and honor to represent the Pennsylvania's 5th Congressional District, which is geographically the largest congressional district in the Commonwealth. There's 18 members of Congress from Pennsylvania. I get to represent 24% of the landmass. At the heart of that, though, is, quite frankly, my alma mater, Penn State University in Center County. Over my time in Congress, I've had the opportunity to see firsthand how the university is leading the field of digital manufacturing in areas that range from 3D bioprinting to cyber manufacturing, robotics, and automation. And it's really pretty cool to be able to visit and to see on our campuses, whether we're talking about University Park or Du Bois campus, those innovations. But what I really like is how my university works with our high schools, because it's exciting to go out and to visit our career and technical education programs, our secondary schools, and to say, hey, do you want to come see our digital manufacturing program, where we're teaching 9th graders and 10th graders and 11th graders and 12th graders about something that really is going to help define the future, the present day, because we're using it today, but also as those innovations continue, the future manufacturing. Those are pretty cool experiences. And it's really cool to see how excited the kids are when you give them that opportunity to be hands-on. And so I really appreciate Penn State and other universities and programs. I know we've got other great programs that are doing the same things in other parts of the country, where they're doing this innovation, but they're not keeping it within the halls of our university. They're partnering. They're reaching out to business and industry and high schools. And if I remember right from my visit last visit to Penn State on this issue, we're reaching out to middle schools, and we're really reaching down to be able to show these kids what are the possibilities, and to excite them so that in the future maybe they pursue a career in engineering, or maybe a career in welding, a career in electronics. Any of the career and technical education areas as well. The 5th District of Pennsylvania has a long history in the powdered metal industry. In fact, St. Mary's and Elk County as well as Cameron County has been known for years as the powdered metal capital of the world. And a few months ago, I visited Penn State to take a look at their work in the field of additive metal manufacturing, which takes place in the university's Applied Research Lab, the CHIMP 3D lab. And it was amazing to watch metal parts to be created using what amounts to a 3D printer. And it's easy to see how this new technology will revolutionize and is revolutionize industries, careers, and our economy. certainly in the powder metal industry, but quite frankly across the board in so many different industries, which has meant so much to our region. In that same vein, I've been so impressed with the university's efforts in hosting an additive manufacturing challenge for small businesses. A great way to, I think, further grow this. The challenge will award 5 companies $40,000 to work with faculty and staff at the Penn State Chimps 3D on projects to demonstrate this amazing technology, the application of it. Now, beyond the dividends these new innovations are paying for the industries which drive the American economy, this research is also benefiting our national defense. Penn State's currently working with the United States Naval Air Systems Command to 3D print, qualify, and certify a critical safety item. In other words, an important part of a Department of Defense vehicle in titanium. Now, that part will be flown in an aircraft next month and will be the first 3D printed part to have gone through the entire process to become flight certified and tested in the military. Very exciting. Now, I commend the pioneers of this exciting new technology from universities such as Penn State, Georgia Tech, Virginia Tech, and along with companies such as the aircraft engine manufacturer Pratt & Whitney, in helping students prepare for what are certainly the careers of the future. As always, a member of Congress, I stand willing and ready to provide any assistance I can, being a partner, working collaboratively to be able to again, promote and encourage and expand this innovation and similar innovations which are good for Americans, good for American families, and good for our country. I really do thank you all for being here, taking the time to be here on a very exciting topic, and thank you so much for the for the privilege, the honor, and the invitation to be a part of your program today. So thank you.